Okay, in this video we're going to take a look at our introduction to basic set theory and using interval notation. So a set is a well-defined collection of things called elements. So for instance, a lot of times in your math classes you may have had a set of answers that may be the solution to an equation. By well-defined in the definition there, we mean that we will know whether or not an element belongs in that particular set. So we have a few ways of describing sets. One of them is verbally, so as you would describe them to somebody in words either written or spoken, as I'm doing right now. We have the roster method, which is where you list out every single element in the set, which isn't so bad if you don't have a lot of things in the set, but if you have a long list, for instance, if you're looking at the number of students in a particular school, typically there's a lot. You probably wouldn't want to have to list them all out. Instead, you can use a set builder method, which gives you a rule to generate the items that are in a set. So for instance, here we have the set A, and we have X is our variable, and this right here after this vertical line is the important part, where X is a positive even integer. So all the numbers that we're going to consider as part of this group, which we're going to label it with A, we can label it any letter we like, but we're going to have all the positive even integers. So 2, 4, 6, 8, 10, 12, 14. So we'll know that, for instance, a negative number doesn't belong in here because it has to be positive. A decimal doesn't belong in here because it has to be an integer. And an odd number doesn't belong in here because it has to be even as well. So the empty set is a set with no elements. The symbol is a circle with a slash through it. And this is oftentimes the notation we use for no solution answers. So in this course, you'll see a lot of no solution answers have this empty set notation where we have the circle with a slash through it. So we're going to focus the rest of this video on writing a set using what's known as interval notation. So interval notation is a shorthand way of writing inequalities. So for instance, and again, looking at the set builder notation here, just focusing on the stuff that's past or to the right of the vertical line here, we have the values of X that are greater than 4 but less than 9. The graph of that on a number line, we would shade all the numbers between 4 and 9, and because we're not including them, we use open circles. And the notation for this, anytime we see an open circle on our graph, or we see a less than symbol on our graph, we use parentheses. So I like to go from the graph to the interval notation. So we have between 4 and 9, all the numbers between 4 and 9, not including 4 and 9 because of this less than symbol. So open circles on 4 and 9, parentheses before the 4, parenthesis after the 9. If we are allowed to equal those values, then they're closed circles. So be careful with your answers that you're communicating whether or not your circles are open or closed. So here we have values of X between 4 and 9, including those endpoints. And for inclusive values, we use brackets. So bracket 4, comma 9, and then another bracket. We can also have a mix and match. We can have one of them have a closed circle where it can equal 4, another one have an open circle where it's not allowed to equal 9. So here we have between 4 and 9 where we are including 4, but we're not including the 9. So any number between there will work. Same thing with switching it up for open circle with 4, closed circle with 9. Here in this group of graphs and set builder and interval notations, we don't have a definite stopping point. So in the last 4 rows of the table, we had between 4 and 9. Here for this one, we have greater than 4, which the greater than has an open circle, and then all the numbers greater than 4 are shaded to the right. And look at how the inequality sign is pointing to the right. That's the same direction we're going to shade. So all the numbers greater than 4, we start at 4, and then all the numbers greater than 4, we go to infinity. And we're going to use parentheses before the 4. And every time you have an infinity involved, if the infinity is the second value in the interval notation, there's always a parenthesis after the positive infinity and always a parenthesis before the negative infinity. For x greater than or equal to 4, this open circle becomes a closed circle. We are allowed to equal 4, so a bracket before the 4, but still a parenthesis after the infinity. Less than 9, open circle at 9, shade to the left. Notice it's pointing to the left. And going all the values less than 9 or to the left of 9 headed towards the negatives on the number line. So we have parenthesis negative infinity to 9 with a parenthesis. And then if it's a closed circle at 9 where it can equal 9, it's a bracket after the 9. All right, we have a couple special answers here. First up, we have all real numbers, which the symbol for all real numbers is this capital R, which kind of looks like you want to like fill it in with a coloring or something like that. This is the mathematical symbol for real numbers. That means everything on the number line gets shaded. Every possible value of x or whatever variable we're using is part of that set. The interval notation is negative infinity to infinity and parentheses there. Finally, we have the empty set, which doesn't have anything in it, so no numbers on the number line, no values are shaded, and the interval notation for that, again, is that circle with a slash through it. All right, so that about does it for this video. In the next video, we're going to take a look at writing interval notation, set builder notation, and the graph of some examples. So I'll see you then.